Hello, greetings. Welcome to A Ramble with me. Today we are rambling about IEB May 2024 paper 2 question 7. Right, let's go. The equation of the circle with center P is x squared plus y squared minus 10x plus 14y is equal to negative 49. So it's not given to us in standard form, boo-hoo. First question says, if the equation of the tangent to the circle at point T 2, negative 3 is 4y is equal to kx plus t, determine the values of k and t. Whoa. There is a lot going on here. Okay, so let's try and envisage what's going on, which is hard to do because just looking at this equation, you can't immediately see what is the center of the circle, what is the radius. So in fact, I am just going to take it upon myself to put it into standard form because that will help me visualize this problem a bit better. So I might not need it at the end of the day, who knows, but I need it. I am saying I need it. I determined that I need it. Okay, anyway, so here we go. X squared plus y squared minus 10x. And in fact, I'm just gonna, why am I erasing the whole thing? Anyway, just marrying from the starting blocks, from the jump, I am already just gonna assist myself and group terms that are, talking about the same variable, right? And all of this is equal to minus 49. The reason why that's important is, of course, because we want to complete the square for the xy parts and complete the square for the ye parts. Okay, so over here we've got our minus 49, and we are going to, hey guys, let us utilize technology when technology allows. Why don't I do the plus as well? Okay, so we're adding it on both sides so that we're not actually changing anything, we're just expressing it in a different way. Right, and then over here we have our plus y squared plus 14y, and then we're going to add this magic term over here, and we're going to add it to the other side of the equation too. Something like that. Right, so then the nice thing about this is that this then factorizes as x plus this number over here, which is minus 5, and then the ye part factorizes as y plus 14 over 2, which is 7 squared. Then now there is manga happening on this side, so let us just let the calculator do its thing. 5 squared is 25, 7 squared is 49. Nice, the minus 49 and the 49 cancel out. Okay, right, so our final answer over here is 25. Right, so what does this tell us? This tells us that the center of the circle is 5 and minus 7, and the radius of the circle is 5. Okay, so now I can try to visualize this problem a bit better. Okay, so we have a circle. Okay, and this circle has center 5, center 5 and minus 7, so maybe like somewhere down here. So this needs to go down, right? So this is 5 and minus 7, and the radius is 5. So we're gonna have a point over here. Minus 7 plus 5 is minus 2. Then if we go straight across from the center 5 units, because that's the radius, that will give us another point on the circle. And then if we go 5 units down from here, we end up there. And if we go 5 units across to the right, we end up with that. Okay, so this is actually probably not even going to work, but anyway, I am hopeful. You see now this circle is already way out. Hey, Sheba. Hi. Okay, I think some of these marks are just, this is so off. That looks a bit more believable. In fact, I'm just gonna get rid of this Mafong Kong here. I don't need you. I don't need you in my life. Okay, so our circle looks something like that. Right. And we are now told, now I can read this question properly. So we are told that there is a tangent to the circle at the point 2 minus 3. So maybe this point is somewhere here. The point T, okay, which is 2. Actually, I don't want to clutter this space too much, but yes, this is our point T, and the tangent is given by this equation, and we need to figure out what K and T are. So we have a tangent. Yeah. Yeah. Okay. So the tangent is something like that. Okay. Yeah. This tangent is really not given, y'all. It ain't given. It ain't given. Yeah. Something like that. That's a bit better. Okay, so we are told that the equation of this line is 4y is equal to kx plus t. Okay, so I mean, I think the most straightforward kind of question with tangents is you're given a point, and this is pretty much it actually. It's pretty much the same standard question of given a point, what is the equation of the tangent at that point? But then we're just going to need to do some fancy stuff to get it into this form at the end of the whole hurrah. But, you know, behind the wolf's skin is actually a very gentle lamb. I don't think the image works that way, but anyway. So what we do to find the tangent is we draw our little r here, right, our radius, and we know that according to tan-rad, those are perpendicular. So if you can find the gradient of this line, then you can use the fact that they are perpendicular, these two lines, to find the gradient of the tangent. So yeah, so then it was necessary to do all of this work so that you could find the coordinates of the center. So now we're gonna say, you know, suppose that the center is some point C. Okay, the gradient of CT, and our t is 2 and negative 3. Okay, so it's gonna be negative 3 minus negative 7 over 2 minus 5. So that is going to be minus 3 plus 7, which is 4, divided by 2 minus 5, which is negative 3. So the answer is negative 4 over 3. Right, and so therefore the gradient of the tangent, which is okay, so first maybe let's just say, you know, for the sake of completeness, CT is perpendicular to the tangent, right, that we're talking about, and the reason is tan-rad. Okay, so then now we can say the gradient of the tangent will be the negated reciprocal of the gradient of the radius of CT. So it will be positive 3 over 4. Right, so now we know that the equation of the tangent looks something like this. Y is equal to 3 over 4x plus some y-intercept c. Okay, let's make some space for our CLs. Okay, so now what we then use to figure out what this is we know that there's a point T on this line. So we're going to sub it in. Okay, so we know that when x is equal to 2, y is equal to negative 3. Then we solve this equation. So we've got 6 over 4, which is 3 over 2, plus something is equal to negative 3. So that will be c is equal to minus 3, which is, you know, the same as minus 6 over 2, minus 3 over 2, right, which will be minus 9 over 2. And our diagram, you know, our diagram is kind of agreeing. Okay, getting a y-intercept on the negative side of the y-axis, so that's cool. So the equation of the tangent at t is going to be given by y is equal to 3 over 4x minus 9 over 2. But now, we want the equation to be in this form, where we don't just have a y on this side, we have a 4y, right? So we're going to need to times our equation through by 4 in order to get right, so times 4 on both sides so that we can have the equation looking like this. So this will become just 3x, and this will become minus 36 over 2 minus 18, right? And so the question is, what is the value of k, which is the coefficient of x, and t, which is the constant? So therefore k is equal to 3 and t is equal to negative 18. Wonderful. Next question says, so still looking at the same circle, if a second circle with equation x minus 4 squared plus y minus 3 squared is equal to r squared has an x-intercept at x is equal to 7, determine whether these circles intersect each other. Okay, so in order to determine whether the circles intersect each other, remember that what we're concerned with is the distance between the centers of the two circles and how that relates to the sum of the two circles' radiuses, right? So we know that there's the three scenarios. There's this scenario where the distance between the circles is greater than the sum of the radii, right? So then we know that these circles do not touch. The second scenario is if we have an overlap like this. So what happens here is that the distance between the centers of the circles is smaller than the sum of their radii, right? The sum of the radii is bigger than the distance between Varingi. Yeah, I lost my train of thought because I was being a clown. Anyway, then the last scenario is where they just touch once, they are tangent to each other, and that is where the distance between the centers is equal to the sum of the two radii, right? Hey, there's also this scenario somewhere, somehow. Hey, can't know what happens in this scenario. So here we're seeing that the distance between the circles is smaller than the sum of the radii, right? So I guess we just have to be careful in those situations. You might find that you've calculated the distance of the center and you found that it's smaller than the sum of the radii. So it could be a situation where there's an overlap, there's two intersections, or it could be a situation like this where this circle is inside the other one and intersects at once. So I guess there's a disclaimer here. Weird case. And I guess that's actually true for hey, because now there could also be a situation where you have a circle and another one just floating inside it. Absolutely no intersections whatsoever. And what happens here is that the distance between the two centers is smaller than the sum of the radii. Oh my god, it's a whole new world out here. So if you just looked at it naively, you would say that if that happens, then there are two intersections. So, but we just have to be careful about could this circle be inside the other circle? Weird things happen when the circle is inside the other circle. Anyway, so let's see. Hey man. The moral of the story is just be careful. Okay, so I'm gonna grab my beautiful drawing of my circle and other things because the diagram got busy very quickly, of course. That was such a perfect selection, and now I'm gonna mess it up. I'm gonna mess it up. Okay, let's see. Duplicate. Let's go. Right, so I'm going to get rid of this tangent because it is now irrelevant. So now our other circle has center 4 and 3, so that will be let's say somewhere over here. Okay, and it has an x-intercept at x is equal to 7, so there is the point 7 0 on this circle, right? So let's try to draw it. Yo. Horrible. Horrible, Tammy. Horrible. Yeah, it's horrible. I can't even look at it. Something like that. Something like that, guys. Something. Right. So now, determine whether these circles intersect each other. So we will look at the length of the radius compared to the distance between these two circles. Oh, adjustment of position. Ew. Old people back giving problems. Okay, so radius of circle 2 will be, we'll use our distance formula here, 4 minus 7 squared plus 3 minus 0 squared. Okay, so then that will be minus 3 squared, so that's 9, plus another 9, so that's root 18, which is 3 root 2. Okay, so that's the length of the radius. Okay, so let's just say big R is equal to 3 root 2. And then little r, okay, we do have a point. We were given a point in the previous question. T, whose coordinates are, we already know the radius. Sorry, we don't need you, T. Get out of here. Get out of here, T. Get out of here. So let's call this radius little r, and we know that that radius length is 5. Okay, so now if we calculate the distance between the centers, so I mean, firstly, we can tell, how can we tell that this circle is not inside the other circle? And which one is bigger? My diagram is very misleading, but this circle is actually bigger because it has a bigger radius. This radius is smaller than this guy, because this is root 25, this is root 18. So this is actually the biggest circle, despite despite false appearances. So how do we know we're not dealing with an inscribed circle, as in a circle that's inside the other one? So because this is the biggest circle, the only possibility would be that this one is inside this one. But we know that it's not, because the highest point of the circle is inside negative y land, right? -7, -5 only gets us to -2. And the center of this circle is like way out of that league. So we don't have to worry that we're dealing with an inscribed circle. Anyway, so now we're going to work out the distance between the two centers, which is 4 minus 5 squared plus 3 minus 7, so 3 plus 7 squared. So that gives us 1 plus 100. Okay, right, so that's the distance between. So I'm just gonna put that in over here, lots of dotted lines. That is D, this guy over here. Okay, D is equal to root 101. I'm quickly realizing that this form is absolutely useless. This is more purposeful. Anyway, and now we want to see what is the sum of big R. Okay, what is the sum of big R and little r? Right, so that will be big R plus little r is equal to well, now I'm swapping them around, but it will be root 18 plus 5. Okay, so we're going to need calci because it's not easy to compare these numbers. So root 101 is 10, 0, blah blah blah. This one is root 18 plus 5, which is 9, 2, blah blah blah. So what do we see? We see that the distance between the centers is greater than the sum of the radii. So these cycles actually don't touch, and my diagram is a lie. It's a lie. Therefore, they don't intersect. Oh my goodness. Gracious me. Dear Lord above. And you know, you can definitely pause, stop the video right here if you don't want to entertain this conversation any further, but I do. So let's see. So we are dealing with a circle. This is the first circle, x squared plus y squared. Oh, I don't even know what I'm gonna do. Okay, I think I know what I'm gonna do. Minus 10x plus 14y is equal to negative 49. Oh, I'm not confident about what I'm gonna do. And then the second circle is x minus 4 squared, I think, plus y minus 3 squared is equal to r squared, which we initially didn't know, but we found out what it was. We found out that r is in fact root 18. So this here, r squared, would be 18. So we want to solve these simultaneously and satisfy ourselves that there actually isn't an x and a y that satisfies both these equations at once. So let me not blind us. Can I use white? Oh my goodness, no, I cannot. Okay, so this would be x squared minus 4x plus 16 plus y squared minus 3y plus 9 is equal to 18. Okay, so this would be x squared minus 8x plus y squared minus 6y, and then 16 plus 9 is 25. 18 minus 25 is minus 7. So this is pretty much this equation written in a different way. Okay, so now what I am trying to understand is whether there really isn't a solution for this system of... Oh, this is not a pretty color. Like, the more I'm doing it, the more I'm like, ayivumi and mnangia foster and go awkward nje. Okay, how would I even solve these simultaneously? Like, two quadratic situations going on. Who tragic? So, I mean, because both equations have an x squared plus y squared, you know, we could eliminate to get a first equation, but then how do I get the second one? Oh, Oh, shucks. Let's use that. I don't know, maybe there isn't a straightforward way to do what I'm trying to do. Just a young girl trying to solve simultaneous equations with two quadratic terms. I don't want to spend too much time trying to puzzle this out, honestly, because in the larger scheme of things, irrelevant. I guess I just in so much disbelief that these two circles don't intersect. Like, what? I mean, I guess, okay, so maybe a very messy thing that can be done is to say, all of that erasing just erased the highlighting. I can take this guy and express x in terms of y, but you can already see the aga is going to be very severe. So this will be plus or minus 18, the square root of 18 minus blah blah, and then x will be one of these, which is also just a weird, hey, x can be usually when you rewrite an equation to make one of the variables the subject, you don't get two possible expressions as the output, but we're dealing with two quadratic terms, so 1 so now we need to, I guess, take each of these expressions in turn and put them in here. This is gonna be too ugly to solve. I don't want to get involved, so I'm just gonna go right ahead and look at what the memo has to say, and we can see if I messed something up somewhere. So where the memo. So first question asked us for the values of k and t, and we got them. Yep, approach looks pretty much the same, so I'm good with that. Then the second question, I just want to chase right to the end and see. They don't intersect. And exactly the same approach. Find the distance between the two centers. First find the radius of the other circle that was introduced in this question, i.e. circle blue, because we didn't know what the radius was, but they did tell us that the 0.70 lies on the circle, so we could use that to figure out r. Right, and then, which you could also have gotten by just subbing in this point, right? So instead of doing the distance formula, even though it ends up pretty much doing the distance formula at the end of the day, if you just subbed in 7 and 0 over here, you'd end up with something that looks like that when you're trying to solve for r. Anyway, so you find the radius, you find the distance between the centers, and then you compare the sum of the radii to that. And because the sum of the radii is smaller than the distance between the circles, and because we also made sure we're not dealing with weird, funky, inscribed circles, then we can conclude that these circles do not intersect. Right. That's enough rambling for the night. Thank you for tuning in, and see you another time.